So on homework 33, we're starting out graphing an exponential function, should say, and its asymptote. On these ones here, they are going to have a horizontal and vertical shift to them. So first thing we're going to do is, if we made this 0, our x value is going to be 4 up there. So we're going to evaluate and find the point where we have e to the 0 power. So 4 minus 4 would give us 0. E to the 0 power is going to equal 1. 1 times 1/3 obviously is 1/3. Then 1/3 plus 3, 3 and 1/3. We're only going to do one other point, and that one other point will just be the next number higher than what we have here. So in this case, we're going to put a 5 in there, which is going to give us e to the first power. And so our y value is going to look really weird, but you're going to be able to punch it in on Alex and it will figure out what the decimal equivalent is. And so what I'm going to have is 1/3 e plus 3. Because if I put the 5 here, we'll have e to the first, which is just e. And so we're just going to type in 1/3 e plus 3, and Alex will put that on there. Our asymptote, normally our asymptote is along the x-axis, but since this graph is going to shift up 3, our asymptote is going to be at 3. So I'm just going to draw my asymptote in there. 4 is at 3 1/3, so it's just a little bit above that. And if I find a calculator somewhere, you don't have to figure out what that is, but so we can plot it, I'm going to go ahead and figure out what that is. 1/3 e to the, just e to the first power plus 3 is 3.9, approximately anyway. So 5 is up at 3.9, so just a little bit higher. And then when you hit the graph button, it's going to put your graph in there, and it's going to look something sort of like that. So when you're graphing those ones with the shift, you'll just use 2 points, one where you have e to the 0 power and one where you have e to the first power, and then put your asymptote on there. So on number 2 there, what would we want to start with for our x value? -3, exactly. -3 plus 3 would give me 0. E to the 0 is 1. 1 times 4 gives me the 4 in front, and then just 4 minus 1, which is 3. So if we use -3 for our first x value, the next number bigger than that would be -2. And when you put the -2 in there, you're just going to have the 4e minus 1. That would just give you e to the first. My asymptote would be at -1. So I'll sketch my asymptote on there at -3. We're up to 3. And then 4e minus 1 would be equal to about 9.8. 9.9 actually. So at -2, we're up at 9.9, and this graph is going to look something sort of like that when you hit the graph button. So on the third one, our first x value would be at 2. And if we put 2 in for x, we would get 2 2/3, exactly. Then we're going to put what in for x? 3 in for x, and for y then we're going to have 3 Exactly. 2/3 e plus 2. So basically it's just getting rid of that exponent because it's making it to the first power where we don't have to put to the first in there. Our asymptote is going to be at positive 2. And so if we go to 2 and 2 2/3, say that's about there. If I do 2/3 e to the first power plus 2, I would get 3.8. So 3 is at about 3.8. And so our graph, again, will look something sort of like that. The next ones we are going to evaluate basically a word problem where they're giving you the information and a formula and you have to plug the information into the formula, but of course you have to know how to get it into the calculator to get it to work, right? It says in number 4, if the rate of inflation is 3.9% per year, the future price, P of t in dollars, of a certain item can be modeled by the following exponential function, where t is the number of years from today. So, $3,000 would be the amount that was invested. 3.9% is the interest. They add 1 because you keep 100% plus the interest, and then it's to the t power. We want to find the current price of the item and the price 8 years from today. For the current price, you're using the time as 0, right? We haven't gone any time. It's right now, current time. So we're going to do 3,000, 1.039 to the 0 power, and it's going to look something sort of like that. That one you maybe don't even need your calculator for. Anything to the 0 power is 1. 1 times 3,000 means my current price is 3,000, right? I just put my money in there. It hasn't changed in value any. I haven't gotten any interest. 8 years from now. So we're going to do 3,000, 1.039 to the 8th power, and we're going to punch that into the calculator. We are going to round to the nearest dollar. Let's see if I have another calculator handy here. And what are we getting? $4,074. That's what I'm getting to. So 8 years from now, my $3,000 will be worth $4,074. The next one, it says a radioactive substance, uranium-240, has a half-life of 14 hours. The amount A of my sample of uranium-240 remaining in grams after T hours is given by the following exponential function. So here they're saying we started with 1,200 grams, we're doing the half-life, and then we have to do T over 14. On these ones on your calculator, because we have to follow the order of operations, you need to put an extra set of parentheses around your other fraction that you have as an exponent. So you're going to put the 1,200 parentheses 1/2 or 1 divided by 2 caret, and then the t is 11 hours, so 11 divided by 14, or you could use the fraction button, either way. But you need that extra set of parentheses because otherwise it'd do the exponent before it did dividing, and so we have to make sure it does the dividing first. So, did you already figure that out? 696, and we're rounding to the nearest gram. Okay. So we started with 1,200 grams. Every 14 hours it's cutting it in half, cutting it in half, cutting it in half. So after 11 hours we have 696. We have a little more than half because we haven't even went our 14 hours yet. after 60 hours. So we're starting with our 1,200 grams. We have our half-life, and we are doing 60 hours out of every 14 hours that it cuts it in half. Which gives us 62. We round it off to the nearest gram. So number 6, the formula looks sort of the same thing. It says a radioactive substance, cesium-137, has a half-life of 30 years. The amount A of T in grams of a sample of cesium-137 remaining after 2 years is given by the following exponential function. So again, we are starting with 621 grams. It has a half-life of 30 years, and so on the first one we're going to do 20 over 30. And we are getting 391. Again, we didn't quite make it to the 30 years, so we have a little more than half left over, right? Then we're going to do after 50 years. So 621, my half-life, and we're going to have 50 divided by 30. Did I punch that in wrong? Try that again. Beta, what'd you get?
Still trying.
You're still trying?
Yeah. I just keep punching too many things. 196.
196. What do you want the negative in front of your half?
Oh.
621, parentheses, and then 1/2, parentheses, caret key, and then parentheses, and we're doing 50 divided by 30. And 196. All right, part B is evaluating an exponential function with base e. E is sort of like pi in the thing that it's an irrational number and it's always the same number. On this calculator here, if you look above the natural log, you see in yellow e to the x power. If I'm going to do e to the first power, what I have to do is I do shift and hit the natural log, and then I just put the exponent right behind it. You could use parentheses around it. If you have a Texas Instrument calculator, it automatically puts the parentheses there, but e to the first power should give you 2.7182, blah, 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 blah. So e is roughly 2.7, but it's one of those irrational numbers that keep going and going and going. So when I'm going to do this one, it says the number of bacteria P of T in a certain population increases according to the following exponential function, where time t is measured in hours, and we want to find our answer after 3 hours. So we would do 190, and then we do the e by hitting shift natural log, and then since I have more than one thing after that, I'm just going to put in parentheses my 0.08 times my time, which is 3 hours. So you don't use a caret key. I don't know why. You think you should. But on this calculator, you don't use the caret key. You just put whatever the exponent is in parentheses behind your number, unless it's just one number. Then you don't need the parentheses. 190. Shift natural log, parentheses, 0.08 times 3. And we are rounding to the nearest gram, so what are you coming up with?
242.
242, that's what I'm coming up with. 242. And like I said, if you're using a Texas Instrument calculator, it automatically puts the parentheses for you, but on Casio, you got to put the parentheses in there. And so after 8 hours, all we're going to do is just change our 3 to an 8. So 190E 0.08 times 8. And rounding to the nearest gram, we get
360.
360, yep. Betty, you getting those to work? So, number 8. Suppose that the velocity v of t in meters per second of a skydiver falling near the Earth's surface is given by the following exponential function, where time t is measured in seconds. And so we've got 54, and then we'll have 1 minus e, and then we're going to have parentheses, negative 0.24. Our time, since it's the initial velocity, would be 0. So times 0, and close our parenthesis for our e power and for our other set of parentheses that we have. And we are getting what for our initial velocity? We get 0. Yeah, they haven't taken off yet. He's probably still in the plane. So he has no velocity. So then we have 54, 1 minus e to the negative 0.24 times 5 seconds. That one I better figure out. Parenthesis. And we're rounding to the nearest whole number.
Is that 38?
I got 38 also. So 38 meters per second is how fast he's falling. Number 9. A species of animals is discovered on an island. Suppose the population size P of t of the species can be modeled by the following exponential function. So we have 400 over 1 plus 7e to the negative 0.1 t. Now we could do it in 2 steps and find our bottom number first and then take 400 divided by the answer, or we need to put parentheses around the entire bottom. So I would say 400 divided by, and since the calculator has to do the bottom part first, we got to put parentheses around there. 1 plus 7e, and then for our e, we also have to have parentheses around that. Negative 0.1 times our time, since the initial size, time is 0. So 50 is our initial population size. This would give me e to the 0, which is 1. 1 times 7 is 7. 7 plus 1 is 8. And 400 divided by 8, hey, is 50. The next one probably won't turn out so nice. After 8 years, so 1 plus 7e to the negative 0.1 times 8. Parenthesis, parenthesis. Negative 0.1 times 8. 96. So our initial population started out at 50. After 8 years, we now have 96 of whatever our species is. The next ones, we are actually going to set up the formula that we need to evaluate then for exponential growth or decay. It says a car is purchased for $28,500. After each year, the resale value decreases by 35%. What will the resale value be after 4 years? Round your answer to the nearest dollar. So our amount is going to be equal to, I'm going to call it the principal, whatever number you started with. Then you're going to have your rate. Your rate has to be the rate that you're retaining each year. So in this case, if I'm decreasing by 35%, what percent am I retaining in its value? It decreases by 35. What does it maintain? 65, right? So our percent's going to be 65 that we're going to use. And then it's going to be to the t power. So we're going to take 28,500 times 0.65 to the 4th power. Round to the nearest dollar, it says. Yep. So 5,087. So we bought a car for 28,500, and after 4 years, now it's only worth $5,000. Hopefully it retains better than 35%. That's not very good. Number 11, it says amount of $27,000 is borrowed for 10 years at 3.5% interest compounded annually. If the loan is paid in full at the end of that period, how much must be paid back? Since this is compounded annually, we don't have to use the compound interest formula. We're basically just using the same formula. And so we're saying $27,000. But we have to be careful on our interest, because our interest, we have the full amount that's in there plus the interest. So for our rate that it's retaining, it's 1.035. 100% plus the 3.5 interest that it's earning, right? We don't lose the money we first put in there, or we don't get to not pay that back. We are going to put that in there for 10 years, so to the 10th power. So whenever you do interest, where it's maintaining its full value, you're going to take 100% plus what the interest is, and that's going to be the interest that or the amount that it retains for the rate. 27,000. 1 plus 0.35 to the 10th power. And we are rounding to the nearest dollar. $38,086. So we borrowed $27,000. Our interest rate was pretty good. After 10 years, we pay $38,086 back. And number 12 is one of those with the half-life. The half-life of a radioactive isotope is the time it takes for a quantity of the isotope to be reduced to half of its initial mass. We're starting with 160 grams. How much will be left after 3 half-lives? So 160 grams. And in here, half-life, you can either use 1/2 like they did previously, or 50%, right? It's retaining 50% of its value. And I like to use 50% because 0.5 is easier to type in than 1/2. Not that it makes any difference. And then for 3 half-lives, so we're going to put a 3 up there. Ada doesn't want to answer anything. 20. So what happened, it started at 160, it cut it down to 80 in 1 half-life, 40 for the next one, and 20 for the next one, right? I could have done it that way. That's what half-life means. The next ones are on compound interest, where I'm compounding more than just annually. Quarterly, 4 times a year, semi-annually, twice a year, monthly, 12 times a year. And so when I have my formula, I have P times 1 plus, and my interest rate I'm dividing by the number of compounding periods. If it's 4% per year compounded quarterly, I'm doing 1% per quarter. My exponent, I have to take my number of compounding periods times my time. And again, I'm going to put that in parentheses because otherwise the calculator will do the exponent before it does the multiply. So, Kayla deposited $4,000 into an account that pays 4% interest compounded quarterly. So 1 plus 0.04 divided by 4 because it's quarterly. To the, so caret key, 4 times a year for 10 years. Now if you really wanted to, you could just do to the 40th power and then you didn't have to do all the parentheses, but if I'm just strictly following the formula, it looks something sort of like that. And these ones we are rounding to the nearest cent, it says. What'd you get?
16,000.
Nope, I didn't get 16,000. Maybe, what did you get?
5,000.
That's what I'm getting. $5,955.45, right? Did you get that, Emily? Still punching it in. Working out all right? Oh, you need 2 to the 40th, or 2 the caret key here, not times. Right, it's 2 that power. So number 14 there. Frank borrowed $8,000 at a rate of 15%. So 1 plus 0.15 over compounded semi-annually, 2 times a year. To the 2 times a year for 3 years. So it's compounded 6 times altogether. $12,346.41. Yeah. So started out borrowing $8,000, ended up after 3 years paying back $12,346.41. I don't think I want a 15% interest rate. That wouldn't be very good. Number 15 then. What formula or what am I going to punch into my calculator in order to figure out what the total amount after 3 years is? So since this one was compounded annually, we really could have just used our first formula, because with all the ones, it works out to the same answer. But yes, if I'm using the compound interest formula, it'd look exactly like that. So 2,000, 1 plus 0.0, whoops, I forget my 0 in there. 26, 2, 0. So if I invested $2,000 at 3.6%, after 3 years I'm going to have $2,223.87. So if I'm only getting 3.6% interest, it's going to take me a long time to make money. Now, they're getting into logarithms. Do you guys have any idea what a logarithm is? What is a logarithm? A logarithm is the inverse of an exponential function. So if I were doing the exponential function to the x power, my logarithmic function would be in base 2 numbers. And then since it's an inverse, they're just switching the x and the y from their table around. So if I did 2 to the first, 2 to the second, 2 to the third, I would switch my x and y column and I'd end up with those same answers. So what they're going to have you do is rearrange. I'm trying to remember which order they put these in. They say b to the a power equals c, I think. Not really that it matters which one's the a, b, and the c. Then they're going to rearrange it. So they're going to say log, the base is b, and then they're basically just switching these. In some books they would use an x and y because that's what inverse function says. You're switching the x and the y. But we're just switching these two things around. So the c would go here and the a would go there. So if I have 3 to the negative 2 power equals 1/9, which is a true statement. 3 to the negative 2 power is 1/9. The base on this is 3. So log base 3, I'm going to put it underneath so I can read it. And then basically you're just switching the answer and the exponent around. So log base 3 of 1/9 is equal to negative 2. Later we'll figure out how to solve those using our calculator, and you'll be able to punch it in and see, yeah, it really is negative 2. But that's all they're really doing is just switching the exponent and the answer around because they're inverse functions.
I thought it was the other way. I thought it was b and c equals a.
It doesn't really matter. They might have written it this way and said log base b of a equals c. Either way, some books use x's and y's. It's just a matter of you switching those two variables. And I can never remember which way it is because I just switch them. So on this one, if I'm rewriting 2 to the negative 1 equals 1/2 as a logarithmic function, my base is 2. So in that little box down there, you're going to have log base 2 of, the next box would be 1/2, and it's going to equal negative 1. So log base 2 of 1/2 equals negative 1. And probably more commonly what you'll be doing is taking the logarithmic function and rewriting it as an exponential function so that you can solve and find the answer to the logarithmic function. So here my base is 2. So 2 to the negative 3rd power is equal to 1/8. And those you know, oh yeah, 2 to the negative 3rd power is 1/8. That's right. If you have them in the wrong spot and said 2 to the 8th power, or 2 to the 1/8 power was negative 3, hopefully you'd say, no, that can't be right. 19, 20, and 21 are doing natural log. It's an ln. It kind of looks like an in on your calculator, but it's really ln for natural log. And a natural log is understood to be base e. They don't write the e there. It's understood to be there. So I'm just going to put x equals y, and then they would rearrange this then to say base e to the y equals x. So it's the same thing. I'm switching my x and y, whichever order the book puts it in. But it's base e when it's a natural log. So we have the natural log of 5 equals y as an exponential equation. I would say e to the y power is equal to the 5. So I'm just switching the 5 and the y around. If I have it written as an exponential function, they tell you to write it as a logarithmic one, which tells me I really have to do natural log since it's base e. I would say the natural log of, and then I'm switching those, 7 equals y. I don't need to put the base e in there because it's understood. So on number 21, if we're rewriting that as an exponential function, we would have e to the x equals 4, exactly.